What's up? Mr. Allen here with the one and only Riverdog Jenny. We're going to do some graphing of exponential functions here, and I have this feeling that it's going to be exponentially fun, don't you? All right, anytime I'm taking a look at a new function here, we're going basic of most basic exponential. F of x equals 2 to the x. I like to throw down a t-chart, especially if I'm not sure what I am working with. All right, so let's start with some easy numbers here. Usually we'll plug in 0 for x as a start, as long as it's part of the domain of the function. And I can raise 2 to the 0 power. So I'll start with that. So let's go 2 to the 0. Anything to the 0 power is 1. How about 2 to the first power? 2 to the first power is 2. 2 to the second power, that's going to be 4. 2 to the third power, that's going to be 8. And I can keep going on and on. All right. What about my negative numbers? Let's add some more on here. I know this is an afterthought here, but how about negative 1? What happens with that? Well, negative exponents give us reciprocals, so it'll behave as if it were 2 to the first, which is 2, but then the reciprocal of that is 1/2. Same goes with negative 2. 2 to the second is 4. We'll flip that. Reciprocal, that's going to end up being 1/4. They don't give us negative numbers. It gives us reciprocals. And then same with negative 3 there. That'd be 1/8. So I got a lot of points that I can plot here. We don't have to plot all of them, but perhaps with this first one we will. All right, so let's start plotting the points, shall we? I'm going to go with yellow for the graph here. I think it might pop nicely. So if I start with 0, 1, I'd have that right here. And then how about 1, 2, right here. And then 2, 4, all the way up here. And then 3, 8. It's going to be all the way up there. Woo! I accidentally jumped too far there. There it is, 2, 4. Okay. So we got this little curvature, but what happens on the left side of the graph there? Well, if I plug in negative 1, I get that 1/2, and then it's 1/4, and then it's 1/8. So it keeps on getting closer and closer to that x-axis. In fact, what's going on there is what's called an asymptote. No matter how negative my exponents get, the number will keep getting smaller, but it will never actually reach 0. So we have what's called a horizontal asymptote running along right there. And we show that with a dashed line. All right. Now it's time to graph it. Boom. I actually did get that on the first try. I was a little nervous. That's why I paused it. So there's my exponential graph. As you see on the left-hand side, it keeps getting closer and closer, but never touches or crosses that asymptote, and it curves on its way up. And it does keep going to the right there. Okay, so let's talk about domain and range, all right? Domain and range are always important. So domain of this function, does it ever stop going to the left? Does it ever stop going to the right? No, so it's going to be x equals all real numbers, or you could write it as negative infinity to infinity, depending on which notation you want to go with. Range, we're talking about our y values, Does it ever stop going low? Yes, it stops at that 0. It never gets to 0, in fact, right? Never gets to 0, but it keeps going up. So if I want to show never getting to 0 but keeps going up, y is greater than 0. Not equal to, just greater than. And if I wanted to do that in interval notation, I'd be going from 0 to positive infinity. Boom, there we go. That's about it with that one. Most basic graphing of an exponential growth function with a base of 2. I think that was awesome. Jenny, what did you think? Was that awesome? Heck yeah, it was. All right, hope you guys enjoyed. See ya.